Thank you for joining us in this presentation introducing the W77Q Secure Flash memory. Here at Winbond, we are very excited to introduce the W77Q. It is our third generation of secure flash memories presenting new approach for IoT security. This presentation covers an overview of the W77Q and one of its main features, the platform firmware resiliency. This presentation is followed by additional presentations covering other key features and topics related to the W77Q. Together with this W75F, the W77Q completes Winbond's portfolio of secure flash memories, suitable for a wide range of applications including financial, automotive, industrial, and IoT applications. With a comprehensive set of features, W77Q is a versatile solution for system security, including platform firmware resiliency, secure storage, remote access, cloud authentication, key management, root of trust, secure boot, and secure over-the-air update. Designing the W77Q, our goal was to simplify IoT security for our customers. The W77Q offloads security functions from the MCU into a single hardware solution, reducing the surface of attack, the design expertise, and design effort required by our customers, enabling them to focus on their core competencies. The device is a fully compatible drop-in replacement for standard serial flash memories. This is functional and pin-to-pin compatibility, making migration of existing systems very easy. There is no need to redesign your board, MCU, or software architecture. The W77Q is designed for secure remote access, so security features could be configured securely even when the device is already deployed. This also simplifies the supply chain security, which can be logically secured with no need for physically secure environment. The W77Q offers advanced security features, platform firmware resiliency, secure over-the-air firmware update, root of trust, secure boot, and secure data storage. The device is targeting local and remote software threats, making it ideal for IoT applications. It is optimized for cost-sensitive platforms, reducing BOM, design effort, and expertise from our customers. This presentation focuses on platform firmware resiliency. Other features and topics are covered in the following presentations. Platform firmware resiliency is defined by NIST Special Publications 800-193. The W77Q provides means to protect against, detect, and recover from unauthorized change of code and critical data stored in the flash. This is achieved by a combination of features. Protection is achieved by cryptographic write protection and rollback protection functions. Detection is achieved by the integrity protection function, and recovery by the safe fallback function and the authenticated watchdog timer. Let's begin with describing the cryptographic write protection and rollback protection functions. The cryptographic write protection function protects platform firmware and critical data from unauthorized change. Each write or erase command must be properly signed using a unique single-use key. An attacker can't change this firmware or data without knowing this key. The rollback protection function protects against rollback attacks. This attack exploits vulnerabilities found in older code versions by replacing existing code with an authentic older version. The older version may be properly signed and authenticated, making it hard to defend against this form of attack. New code version is accepted by the W77Q only if the new code and its version tag are authenticated, and the new version tag is newer than the old version tag. This is done internally by the W77Q in one atomic failsafe operation. Next, we'll discuss the integrity protection function. The integrity protection function detects unauthorized change of code or critical data. Integrity is verified when memory content is updated or accessed, or when manually instructed by the user. Bootcode integrity can be automatically verified on reset. Access is restricted if integrity is compromised. A failed integrity check could trigger the safe fallback function for system recovery. This enables the secure boot directly from Flash, doing execute in place with no code shadowing. Last but not least, we'll discuss the recovery, implemented by the safe fallback function and the authenticated watchdog timer. The safe fallback function is used to recover from unauthorized change of boot code stored in Flash. After reset, boot code integrity is automatically verified by the W77Q. A failed integrity check of primary boot code will redirect execution to alternative boot code used for system recovery. This redirection is executed by the internal mapping function. The MCU is agnostic to all this and does not need to do anything other than execute the code as it normally does. The authenticated watchdog timer periodically restores the system to a state of integrity by forcing clean boot. This happens whenever the system fails to periodically reset the timer by issuing touch commands. The W77Q implements a standard or an authenticated watchdog timer. An authenticated watchdog timer requires authenticated commands to configure or reset the timer. A remote trusted authority can force devices to clean boot by denying such touch commands. This can happen even if devices are compromised or otherwise irresponsive. The W77Q Secure Serial Flash memory is introduced. It is a fully compatible drop-in replacement for serial NOR flash memories. It offloads security functions from the MCU into a single hardware solution, reducing the surface of attack, design effort, and required expertise. It is targeting remote and software threats, making it ideal for IoT security. Its key features are platform firmware resiliency, secure over-the-air firmware update, root of trust, secure boot, and secure storage. Thank you for joining us. We hope to see you in the following presentations.